So the photoelectric effect is something important I need you guys to be able to understand. It's the effect of when light shining on a metal will make electrons emit. And those electrons only emit if the light is above a certain frequency. Otherwise, it does not. And we'll look and see how we can, use this photoelectric effect for different purposes, technology. But here's the thing: you have a voltage been applied here, so electrons want to go. You shine light on here, and then electrons get emitted, and they will go on to the other side because you have a positive terminal of the battery over here. And so when you have enough energy light, like blue light here, then electrons get emitted and they will move on to the other side. Otherwise, that does not happen. So we have current flowing when there's enough energy, but not when there is not enough energy because it's not releasing the electrons to be able to get to the other side. So again, it is the ejection of electrons from certain metals when light falls upon them. Those metals are supposed to be photosensitive. Okay, alkali metals are good photosensitive materials, and that's because they have one valence electron, and it's easy to take those out. Applications. We talked earlier about the smoke detectors, the radioactive ones. That was the old days. Now we have a phenomenon that uses the photoelectric effect. And so we see that as long as light is going across from here, we have that circuit and we have that path going on because it's constantly emitting electrons, and we have a circuit. As smoke comes in the way, then the light does not make it to the other end because the smoke diffuses the light. It doesn't get to the other end. And so we go back to that circuit that if light doesn't fall on there, then the current stops flowing, and that can set up an alarm. And that could be the way that you detect smoke in the room because it blocks out the light that is going from one point to the other. You see a similar phenomena with your garage door openers as well. There's that beam of light that's going across, and if you cut that beam, then the current won't flow anymore, and it closes the circuit. Night vision devices are the same thing. They take the light that's coming in, and that light goes ahead, and even if it's your low intensity light, you have a metal here that can get excited by that light which is coming in the IR range, and that releases the electrons. And based on which parts of the screen get excited, we have those electrons coming out, and so we can create a visual image of that with the different intensity patterns. Solar panels use the same thing. Again, light falls on the solar sensitive material, and the electrons are emitted and become part of the circuit, which causes the voltage that we need to produce power. Again, here's the garage door opener. You see that the light beam is going through here, and if it does go through here, it ejects the electrons it needs to create the circuit, and you have a flowing circuit. But if you come in the way, then that circuit breaks and it does not allow the garage door to close, thank goodness. We've seen photocells being used for your calculators, for aperture control on cameras, burglar alarms. So, anytime that beam is broken, you know that someone's gone through, and that can set off an alarm. So these are all really interesting ways that the photoelectric effect can be used for technology. So do keep in mind that the photoelectric effect and the wave-particle duality are two important features that I need you guys to understand and be able to answer questions to. Okay? So we'll talk to you later. Thanks for now.